So we have solved up to question number 6. Now let us solve question number 7 from the practice sheet. Question number 7 says a copper rod of diameter 1 centimeter and length 8 centimeter is drawn into a wire of length 18 meters of uniform thickness. Find the thickness of wire. Okay. So it says that there is a copper rod which is 1 centimeter in diameter and 8 centimeter in length is drawn into a wire. I have converted that copper rod into a wire. It means whatever the copper that copper rod contains is used to make the wire. Okay, all the material, all the copper is used to make the wire. So the quantity of copper will not change. Okay, since the quantity of copper will not change, it means the volume that copper rod has is same as the volume that wire is going to have. Okay, so this is the concept in this question. Again, this question is based on conversion of solids. What we can see is, let us say this is a copper rod. This is a copper rod. So a rod looks like a cylinder. A rod is basically a solid cylinder. The diameter of this copper rod is given as 1 centimeter and the length of this copper rod is given as 8 centimeters. Okay. Then it is converted, this copper rod is converted into a wire. So let us say wire is something like this. Let us say this is a wire. Okay, the length of the wire is 18 meters and the thickness of wire, that is what we need to determine. So what you can see is that this 8 centimeter copper rod is converted into 18 meter wire. So just think about the property of this copper, that just 8 centimeter of wire is converted into 18 meters. Okay, we have reduced its thickness so much that its length has become 18 meters. Okay. Okay, so the condition is that since all the copper that is contained in this wire, in this rod, is used to make this wire, so the volume of copper in wire is equal to volume of copper in rod. Okay, volume of copper in wire is equal to volume of copper in rod. What we can observe is that the rod is a cylindrical solid figure and as well as the wire is also a cylindrical solid figure. Okay, wire looks like a cylinder. So what should be the volume of wire? If I assume that the radius of this wire is, let us say, r. Okay, let us assume r is the radius of wire. Okay, r is the radius of wire. So what we can observe is the volume of copper in wire can be calculated by using the volume of this wire, that is a cylinder. So volume of this cylindrical wire. Okay, and what is the volume of cylinder? It is pi r square. Now what is the radius? Radius is unknown, that is r square, and into h. What is h? H is the length or the height of this cylinder. Okay, the height of this cylinder or the length of this cylinder is 18 meters. It means it is 1800 centimeters. Okay, 18 meters is equals to 1800 centimeters. Now why I have converted this length into centimeters? It's because I can see for the copper rod it is 1 centimeter, it is 8 centimeters. So the unit that is used is centimeters. That's why I have converted the unit of this length of wire into centimeters. Now further, this is equals to volume of copper rod. This is the copper rod. So volume of this rod is pi r square. What is the radius of this wire? Radius of this rod? Radius of this rod is half of this diameter, that is 1 by 2 centimeters. So pi into r square, that is 1 upon 2 square into h. What is h? H is 8 centimeters. Okay. So h is 8 centimeters. Now further solving this pi and pi term will get cancelled and you will get r square is equals to 1 upon 4 into 8 upon 1800. So you can get, this is 4 ones are 4, 4 twos are 8, then 2 ones are 2 and 2 nines are 18, so 900. So r square is equals to 1 upon 900, which implies r is equals to square root of 1 upon 900. 900 is the square of 30. So you will get r is equals to 1 upon 30 centimeters. Now this is the radius of the wire. So is it our answer? Is it our answer 1 upon 30 centimeters? No. 1 upon 30 centimeters represents the radius of the wire, but I need to calculate the thickness of the wire. So thickness of the wire means diameter of the wire. Okay, thickness of wire implies diameter of wire. If radius is 1 upon 30, then diameter is 2 upon 30, that is 1 upon 15 centimeters. Okay. So just think about 1 upon 15 centimeter, it means I have divided 1 centimeter into 15 equal parts. So this much is the thickness of this wire. So just see the technology that this copper, which is of 1 centimeter thickness, is converted into a thickness which is 1/15th of the actual copper rod. Okay. So this is the thickness of the wire. So we have calculated the thickness, and this is the solution for question number 7. You can see this question is easy, just the formula for conversion of solids. Okay. Then let us move to next question, that is question number 8. Question number 8 is, how many silver coins 1.5 centimeter in diameter and of thickness 2 millimeter must be melted to form a cuboid of dimensions 5.5 centimeter cross 10 centimeter cross 3.5 centimeters. Okay. So it says that how many silver coins should I use to make a cuboid, and the dimensions of cuboid are given. It means the silver that is contained in the coins should be used to make the cuboid. Okay. So obviously I cannot use only single coin to make such a big cuboid, because the silver coin is very small. It is 1.75 centimeters in diameter and just 2 mm in thickness. So that's why I need to use, let us say, x number of coins. Okay. So what the task here is that all the silver that is contained in x number of coins should be used to make the cuboid, should be used to make the volume of the cuboid. So definitely what we can see is, this is the question of conversion of solids. I am converting the shape of the silver coin into a solid cuboid. So what we can observe is, let x number of coins are used to make cuboid. Let x number of coins are used to make the cuboid that is required, and if I draw a cuboid, so this is a cuboid. The dimensions of this cuboid are given as 5.5 cross 10 centimeter cross 3.5. So this is 10 centimeter. Okay, then let us say this is 3.5 centimeters, and let us say this is 5.5 centimeters. So I need to make this cuboid, and to make this cuboid I need silver coins. The dimensions of silver coins are, this is a silver coin, the length or the height or the thickness of this silver coin is given as 2 millimeters, plus the diameter of the silver coin is given as 1.75 centimeters. So what I can see is that it's very easy to calculate the volume of the cuboid. Then what about coin? You can see this coin looks like a cylinder. Okay, the shape of this coin is cylindrical. So whatever the volume, whatever the silver this silver coin contain should be used to make this particular cuboid. So let us say I have applied X number of silver coins, I have melted X number of silver coins, and from them I have made this cuboid. So what I can observe is that whatever the silver, whatever the volume the silver has in silver coins is completely used to make this cuboid. So mathematically I can write volume of X number of silver coins is equals to volume of cuboid. Okay, because all the silver that is contained in X number of coins is used to make this silver this cuboid. Now what should be the volume of X number of silver coin? What is the volume of one silver coin? Volume of one silver coin is, volume is equals to what? It is a cylinder. The volume of cylinder is pi r square h. What is the radius of the cylinder? It is 1.75 divided by 2. Now this is in millimeters, this is in centimeters. What should I do? So just remember that whenever you have a question, whenever you have a situation in which you have different units, try to convert all the units in the smallest unit. Okay, try to convert all the units in the smallest unit, because it will ease your calculation. For example, I can see I have millimeters and I have centimeters. So should I convert this millimeter into centimeter, or should I convert this centimeter into millimeter? It will be more convenient if I convert this centimeter into millimeter, because the millimeter is a small unit. Okay, otherwise you may get confused in the decimals. So to avoid the confusion in decimals, to avoid such calculations, we should convert all the units in the smallest form. Here I can see this is in centimeters, so I should convert this into millimeters, because it will ease my calculation. So how to convert this millimeter and centimeter? What I can observe is that 1 centimeter is equals to 10 millimeters. This is the conversion unit. Okay, 1 centimeter is equal to 10 millimeter. Then what is 1.75 centimeter? So 1.75 centimeter is multiplied by 10 and it will give you 17.5 centimeters. Sorry, 17.5 millimeters. Okay, so 1.75 centimeter means 17.5 millimeter is the unit, is the diameter of the silver coin. So the volume of the silver coin will be pi r square. Now r is 17.5 by 2, because 17.5 is the diameter square. Okay, this is the radius of the silver coin, and the width of the silver coin is 2 mm. So pi r square h. Height is 2 mm. I have converted all the units into millimeter. So what about this? This is 3.5 centimeters, it means 35 mm, 35 millimeters. This is 10 centimeters, means 100 mm. And this is 5.5 centimeters, it means 55 mm. Okay, millimeters. Now the volume of one silver coin is pi into this r square into h. So what is the volume of x number of silver coins? The volume of x number of silver coins will be x into pi into 117.5 upon 2 square into 2, okay, is equals to volume of cuboid. Now what is the volume of cuboid? It is L into B into H. L is 35 into B into H. This is the volume of the cuboid that I am using. So what I can see is I have converted this mathematical equation into this numerical values. I have substituted all the numerical values. Now the next task is to solve this. So it will be x into now pi. Pi can be written as 22 upon 7 into this is 17.5 upon 2 into 17.5 upon 2 into 2 is equals to 35 into 100 into 55. Now let us solve this. I will cancel this 2 with this 2, then I will cancel this 2 with this 11, okay, then I will cancel 11 with this 55 as 5. Now I will be left with x into 17.5. So what I can do is I can remove this decimal and I will get 10 in the denominator, and again I will remove the decimal and get 10 in the denominator. So I can see that this is the 5 and this is a 7. This is 175. So 7 ones are 7 and 7 25 times is 175. Okay. Then this is 5 ones are 5 and 5 5s are 25. Then this is 5 7s are 35 and this will give you 5 ones are 5. Then this is 7 ones are 7 and this is 7 25 times. Okay. So further you have this is 25 as 1 and 25 fours are 100. So you will get x is equals to 4 into this 10 and this 10. So you will get x is equals to 400. What is x? X represents number of silver coins that I need to use. So to make a cuboid of silver of this dimension, I need to use 400 coins of this category, 400 coins of this dimension. Then only I will be able to make this cylinder. Okay. So this is the solution for 8th question. What you can see is just simple conversion of this metal from the silver coin into another shape, that is cuboid. Okay. So this is the solution for 8th one. Okay. So first you note this, then we will continue. Okay, let us now solve question number 9 from the practice sheet. Question number 9 says a cylindrical bucket 32 centimeter high and with radius of base 18 centimeter is filled with sand. This bucket is emptied on the ground and a conical heap of sand is formed. If the height of the conical heap is 24 centimeters, find the radius and the slant height of the heap. Okay. So what the question says is that there is a cylindrical bucket that I have, and this cylindrical bucket is 32 centimeter high and the radius of this cylindrical bucket is 18 centimeters, and this cylindrical bucket is filled with sand. Okay. So it is completely filled with sand, and then what I did is I emptied that bucket on the ground and made a conical heap, okay, a conical shape using that sand. Which sand? Which is contained inside the cylindrical bucket. It means whatever the volume of cylindrical bucket is, that is the volume of sand that it contains. Okay, the volume of sand inside the bucket is the volume of cylindrical bucket. So definitely the volume of cylindrical bucket is the volume of the sand that is used to make the conical heap. Okay, so what I can say is whatever the sand is contained in the cylindrical bucket has the same volume as the sand which is used to make the conical heap. So what I can write in this question is, the condition that I can write is in question number 9, that volume of sand in cylindrical bucket is equals to volume of sand used to make conical heap. Okay, the volume is same in both the cases. So the cylindrical bucket is something like this. This is a cylindrical bucket. Okay, the height of this cylindrical bucket is given as 32 centimeters. The height is 32 centimeters, and I have the base radius as 18 centimeters. Then the sand which is contained inside this bucket is used to make the conical heap. So the conical heap has a shape something like this, a conical shape. Okay, it says the height of the conical heap that is formed, the height of this heap is 24 centimeters. Okay, the height of this heap is 24 centimeters. So my task is to determine the radius of this conical heap. Let us say the radius is r, and another task is to determine the slant height of this conical heap, which is, let us say, L. Okay, so I need to determine r and L. And what is the relation between the two figures is that the volume is equal to volume. This is the condition that we have. What I can say is that the shape of the sand in this cylindrical bucket is cylinder. Then what I did is reshaped the same sand into a conical heap. That's why both the volumes are equal, because the amount of sand is equal in both the cases. So if I take the volume of this cylinder, what should be the volume of this cylinder? It is pi into r square. R is 18 into h is 32. Okay, so here I can write pi r square is 18 square into 32, pi r square h. This is equal to the volume of this conical heap. What is the volume of this cone? Volume of cone is 1/3 pi r square h. So here I can write the volume as 1/3 pi r square. Here r means the radius of this conical heap. R square. Remember, the radius of this cylinder and radius of this conical heap are not same. It is not given that the radius are same. Okay, so 1/3 pi r square into h. H is 24. Here I can write 24. So now just by solving this pi and pi will get cancelled. Here I will have 4. 8 3s are 24 and 8 4s are 32. Here is this r and r will get cancelled, and I have r square is equals to 18 square into 4 is 2 square. So r is equals to 18 into 2, that is 36 centimeters. So the radius of this conical heap is 36 centimeters. So we have calculated the radius. It's very simple, just by comparing the volume. Then what about slant height? The formula for slant height is, you can see this is a right angle triangle. This is, let us say, O, this is, let us say, A, and this is B. O is the vertex or apex of this cone, A is the center of the base, and B is the point at the point where this lateral side and the base are getting intersected. So in triangle OAB, this angle is 90 degree because this is a right circular cone. So this angle has to be 90. Here I can write this OA represents height. Okay, this AB represents radius, and this OB represents slant height. And this is a right angle triangle, so I can apply Pythagoras theorem. What I can write is that lateral, the slant height L square is equals to OA square or H square, or let us write it OA square, plus radius of the base is AB square. So using this formula, I can determine the value of slant height. L is equals to square root of OA. OA represents the height, which is 24 centimeters. So 24 square plus R. AB is R, which is 36. Just now we have calculated. So this is 36 square. So this is the value of L, that is the slant height. Okay. You can calculate this. It's very easy calculation. Square of 24, square of 36, then add and then square root, and you will get the value of L. Okay. So this is the solution for question number 9. You can see question is not at all difficult, only the thing is about visualization and calculation. Just a basic concept that you need to understand, that in case of conversion of solids, always try to understand that the volume should be same. Volume has to be same, okay, because we are converting solid in from one shape into another shape. We are not changing its chemical property or physical property or anything else. We are just converting its shape. We are just changing its shape. Okay. So this is the 9th one. Let us move to 10th question. Question number 10 says, water in a canal 6 meter wide and 1.5 meter deep is flowing with a speed of 10 kilometers per hour. How much area will it irrigate in 30 minutes if 8 centimeter of standing water is needed? Okay, so let us try to understand the question. It says that there is a canal. The width of that canal is 6 meters. Okay, the canal is 6 meter wide and the depth of the canal is 1.5 meter. Okay, so this is the width and this is the depth. And from this canal the water flows at 10 kilometers per hour, at the rate of 10 kilometers per hour. What does it mean? This is the width, this is the height or depth of the canal, and water is flowing like this. So what I can see is that this is 6 meter wide, this is 1.5 meter, which is depth or the height of the canal, and since water is flowing like this, so the shape of the water in the canal is a cuboidal shape. Okay, what we can see is question number 10. I can write that shape of water in canal is cuboidal. Okay, why cuboidal? I can see that this is the canal, this is the 6 meter wide canal, this is the height of the canal, which is 1.5 meters. So water is flowing from this canal like this. Okay, like this. You can assume this canal as a rectangular pipe. It's a rectangular pipe and water is flowing like this. Okay, in this direction. So what I can see is in 1 hour water will travel 10 kilometers of distance. So in 1 hour, how much volume of the water should travel from this canal? I can say that since the width is 6 meter, this height is 1.5 meter, and in 1 hour, if I talk about in 1 hour, I can see that the length in which the water is spread in this canal like this, the length in which the water is spread is 10 kilometers. So in 1 hour I can draw the diagram of this canal as something like this. Okay, something like this. I can draw this canal as like this, in which this is the length of water, the distance that water travelled in 1 hour. This is 10 kilometers, and the width of the canal represents this, which is 6 meters. and the height of the canal is 1.5 meters, or the depth of the canal. Okay, the water is flowing in this canal like this, in this direction. So the volume of water that can flow in 1 hour, the volume of water that can flow in 1 hour should be contained in this kind of cuboid. And the volume of this cuboid is what? The volume of this cuboid can be calculated as, this is the length, this is the width, and this is the height. Okay, so what I can write is volume of water that can flow in 1 hour is equals to what? Is equals to volume of this cuboid, that is 10 kilometers, it means 10,000 meters. Okay, 10,000 meters, because 1 kilometer is 1000 meter. So 10,000 meter into 6 meters into 1.5 meters. This much is the volume. So just calculate it. 15 into 6 is 90. So this will be 9, and you will get 90,000 meter cube. Okay, so 90,000 meter cube of water will flow out from this canal in 1 hour. So what I can see is, if in 1 hour this much is the water that can flow out of this canal, then how much water will flow out in 30 minutes? So water, or volume of water that flow out in 30 minutes from this canal is equals to exactly half of this much volume. So this is 90,000, half of this is 45,000 meter cube. Okay, so 45,000 meter cube of the water can flow out from this canal in 30 minutes. Try to understand this concept. 90,000 that I have determined, I have told you that if the water travels at 10 km per hour, so it means this much is the length that water can travel in 1 hour. So the volume of the water that can flow in this canal in 1 hour is 10 km into 6 into 1.5, because the shape of the water is cuboidal shape, it's in cuboidal shape. Okay, it is not given that the canal is of a cylindrical shape or something else. It clearly says that canal is 6 meter wide and 1.5 meter in depth. Okay, if it would have been a cylinder, it would have been clearly given that the diameter of the canal is something like this. Okay, but here it is clearly given that 6 meter is width and 1.5 meter is the depth. That's why I can assume very easily, very comfortably, that this is definitely a rectangular canal. Okay, so here we have the water that can flow out from this canal in 30 minutes, that is 45,000 meter cube. So if I talk about this water, this 45,000 meter cube water is used for the irrigation. Okay, I have used this water for the irrigation purpose. Now if this water is used for irrigation purpose, how much area I can irrigate using this water? It says that you need to determine the area of the land that can be irrigated using this water if the standing water is of 8 centimeters. What does this mean by standing water? It means that for irrigation, it is important that the level of water on the land should be 8 centimeter at least. Okay, at least 8 centimeter of length is required for the irrigation purpose. Now if I assume that, let us say this is a land, let us say this is a land. Now land, if I am talking about land, I assume that it is a rectangular shaped land. Okay, on this land, if I pour water, if I put water on this land, the level of water should be at least, the level of water that is required for irrigation should be at least 8 centimeters. Because if the level of water is below 8 centimeter, it is assuming that the irrigation cannot happen. Okay, irrigation is not possible. Irrigation is possible only if the level of water from the ground is 8 centimeters. So let us assume that the area of this land that we are using is x meter square. Okay, let us assume, let area of land that can be irrigated is equals to x मीटर स्क्वायर. ओके, हम ऐसा मान लेते हैं कि x मीटर स्क्वायर एरिया की लैंड को हमें इरिगेट करना है, लेकिन कंडीशन क्या है? कंडीशन है कि उस लैंड पे 8 सेंटीमीटर हाइट वाटर की कम से कम होनी चाहिए, तभी वहां पर इरिगेशन पॉसिबल है, अदरवाइज पॉसिबल नहीं है. तो अगर x मीटर स्क्वायर एरिया को मैं इरिगेट कर रहा हूं जहां पर वाटर का हाइट 8 सेंटीमीटर है, देन वॉल्यूम ऑफ वाटर कितना होना चाहिए फॉर दिस पर्पस? ओके, वॉल्यूम ऑफ वाटर कितना होना चाहिए? इफ आई टॉक अबाउट हाइट ऑफ 8 सेंटीमीटर, आई कैन से दैट वॉल्यूम ऑफ वाटर required to irrigate x meter square land if height of water or the water level is equals to 8 centimeters, then what should be the volume of water required to irrigate this x meter square land? If the level of water should rise by 8 centimeter, okay, the level of water is 8 centimeters, then the volume is equals to x square, that is x into 0.08. okay, what is 0.08? It is this 8 centimeter height is converted into meters. Why? Because we have calculated the volume of water here in meter cube, so that's why I have used here the volume of water that is required to irrigate x meter square of land is in meter cube again. Okay, so the height is 8 centimeter, this 8 centimeter is converted into meters. So this much volume of water, this much water is required to irrigate the land. And what is the volume of water that I have? I have 45,000 liters of 45,000 meter cube of volume. So 45,000 meter cube of volume should completely be used to irrigate this much volume of land. Okay, this much area of land where I need this much volume of water. So what I can write is x into 0.08 is equals to 45,000, because this is the volume of water that I can have in 30 minutes. This is the volume of water that is required to irrigate x meter square of land if the standing water is 0.08 meters or 8 centimeters. So x is equals to, where x represents volume, area of this land. So x is equals to 45,000 into 100 divided by 8. Okay, in meter square. So this much area can be irrigated using this volume of water in 30 minutes. Okay, so you can solve this. This calculation is very easy. So this is the solution for 10th question. Okay, so first you note this, then we will continue.